Thank you. So I'm not an academic, so I just have big pictures. So we're talking about Internet of Things, Internet of everything, connecting absolutely everything around us, connecting our households, connecting our cars, our offices, our factories, the supply chain in which we work. Seems on the surface that shouldn't be all that particularly hard, but it gets really complex. If I came to your office right now and I said, hand me your smartphone, hand me your computer, hand me your tablet, now complete your job as you do it today without any of that technology. I, for one, would enjoy someone taking away my phone for a little while, but the problem is we all get anxious. We live in a connected world. We live off of that information. We are required to deliver that information back to others. If I took away the fundamental tools that we have today in our lives, you couldn't do it. You couldn't then connect to everything. And why is that relevant? Well, the reality is, in certain parts of our economy, we think about a certain supply chain. The supply chain in our business, or anyone else's business, is ultimately connected to other supply chains. It's a global economy, and it's all interwoven and interconnected. So when you start thinking about connecting everything, what is everything? It becomes a lot of things. So if we start to think about an IoT strategy for an individual business, whether you're in transportation or logistics or whatever, we got to step back 20 years, 30, 40 years, and think in terms of how people operated with a clipboard, carbon paper. Some people in this room may not know what that is, a typewriter. But if we start there and we think about how an operating environment where everything is connected changes our world. If I came back to your office and said, now 10% of everybody in your group, 60% of your organization, turn in all your computers, turn in all the smartphones, turn in everything, but do exactly what you do today. Mail, filling in ERP systems, going to SharePoint, sharing documents, doing all of it. Do all of that every single day. At the end of your day, you still had to put it into a computer. You just had to go somewhere else to go put it into a computer, or hand someone all your paperwork so they could do that. Could your organization be efficient? Could you be profitable? Could you be globally competitive? If I told you that 240 companies out of the Forbes Global 2000 list operate in that environment, that'd be unreasonable. It'd be ridiculous. But that is in fact the case. Those 240 companies represents $6.2 trillion in cumulative revenue. $6.2 trillion and over $9 trillion in assets. So what's $6.2 trillion? Well, I had to go figure it out. So that's the federal budget and every state budget. And that's still not enough. And every single local budget in the United States. All combined is roughly $6.3 trillion. So I'm off by about $50 billion, $100 billion. But that's a lot of money concentrated by 240 companies where people operate on clipboards. Why in the world is that the case? Well, and where? It happens to be economic driving industries around the globe. Those that our supply chain, whether or not you make a bow or a package or a restaurant or whatever, those industries impact every other business around us. Why is that? Well, coincidentally, these industries happen to operate hazardous environments. When I say hazardous, I mean areas that are prone to explosion because there's a presence of the liquids, gases, dust, particulates, fibers. Because of the presence of those in concentration, any type of ignition, well, would generally be bad. And so there are certain regulations that, in fact, prohibit the use of most electronic devices in those environments. So our smartphone, you can't carry into a refinery. A tablet, you can't carry into a chemical plant. The stories you use in your phone next to the gas pump, I will say, having sat in labs and said that's not possible and watched things go poorly, I now don't use my phone inside gas pumps and other things like that. It is remarkable how small of a spark can create a really catastrophic circumstance. So as a result, when we start thinking about connecting everything, yet industries operate where they're still on clipboards and paper, there's a slight disconnect. So why does all this matter? If we just focus for a moment on the oil industry, petrochem markets, focus on what they're looking at. Because of the price of oil, there's been a significant impact. Roughly $350 billion in capital has not been spent and will not be spent, or has been delayed on specific projects. That means no exploration, no advancements in efficiency. Over the next couple of years, the excess supply that's in the system will be absorbed. But with no advancements in those markets, fundamentally what's going to happen? Prices are going to rise. How do you head that off? Well, McKinsey did some interesting research not too long ago, and they showed that in the oil industry, 1% of data is currently being analyzed and acted upon. 1% of available data. How do you get efficient in a world like that? There's so much great information that can be mined. There's so much incredible knowledge that can be gleaned. If a modest improvement of a digital transformation existed in that environment, upwards of 10% in additional earnings would occur. 10% in a world where just 240 companies are generating $6 trillion in revenue. That becomes a real number. That becomes an economic driving number. That affects the global economy and affects all of our supply chains. So, is this real? Is this reasonable? Now, I can tell you I toured a facility not too long ago, about 6-9 months ago, and senior executive at a well-known company was very proud of this process where people walked around with their clipboard and they filled out a form. At the end of the guy's shift, 4-hour shift, paper's kind of smudged and so forth, and he walks in and now he's ready to enter that information in about 5 hours after he's captured that information. Now, things happen in refineries where real time would be kind of valuable. 5 hours seemed good enough. Now he had on that piece of paper a perforated section that they're very proud of. Look, see, it's perforated now. They've learned. And you could tear that perforated piece off and you could put it up on a push board, or pushpin board. And somebody, whenever that piece of paper made it to that pushpin board, that alerted other people in the control room that there's a situation. And someone will walk over and take it off and go enter it into a system. And I made a comment, I said, well, what happens if the piece of paper falls off the pushpin board? And whoa, don't even do it. And so I recommended they move to magnets. Anyway, I haven't won an innovation award with them yet. But, so how do you do it? Kind of talk about why. Why? Because it's important and it's significant. But how is really hard because these places are massive. They're huge. There are hundreds of different microclimates. So how chlorine moves, or methane, or benzene, or whatever moves through the air is really challenging to analyze. The types of computing and analytics would be immense to solve that on one facility, much less the thousands around the globe. I had a chance to go to another facility in Europe. That particular plant covered 10 square kilometers. It just felt like you just kept driving. We're still passing it. We're still passing it. And in that particular location, used 3.4 million megawatts of power in a year. 3.4 million megawatts. I have no idea how many households that is or light bulbs, but what I can tell you is that's more power than the entire nation of Denmark. One plant. So, sitting with some other analysts and people, we're all kind of thinking through this and talking through, how do you solve this? How do we make this actionable information? How do you monitor how steam moves through that plant? It's breaking these things apart and smashing these things together to make all these incredible compounds that all of our lives require. And if we could just manage that heat slightly more efficiently, it was determined that we could save nearly 20% of their annual power consumption. That would be the reduction of power in the entire nation of Denmark by 20%. And that can be done within a period of almost a year. And how much does it cost? I can assure you that the little sensors don't cost that much money. an ROI in months. Truly remarkable. That same amount of power consumption was roughly 2.8 million tons of greenhouse gases. A reduction of 20% has an impact on a continent. It has an impact on our planet. So IoT, it's a confusing, vast world, but the impact is immense, and it impacts all of us. So, now kind of into the fun part. We had to figure out how to do this. You can't just start putting electronic devices all inside of refineries, chemical plants. They get a little upset by that. And you can't test there because it's dangerous. So here in Georgia, conveniently, education is important to all of us. We happen to have one of the coolest, best education playgrounds on the planet. Here in Georgia, about 2 hours south of Atlanta, in Perry, Georgia, is this amazing place. It's the world premier training facility for first responders, for disaster recovery and training, for people in defense and homeland security. This huge, incredible place, which has a subway station on it, has a 4-lane underground highway, it has an above ground highway. We can go and we can start and we can test there. We can release gases and see what happens. What happens in microclimates? What happens? And with that really cool, fun place, we could create just a range of different environments that we can mimic the same industrial place or even just simply a smart city, an urban complex. Chlorine spills, how do you trigger all the green lights to turn green in that direction to move traffic out? How do you apply the same things we do at a factory into an urban environment and impact the community? So we set out and started planning some sensors and doing some things around it, kind of a basic IoT concept. And what we learned very quickly is A, I don't like wiring this stuff in August in Perry, Georgia. And B, it didn't work. In that really vast, giant scale, it becomes really, really difficult because, and we've started to refer to this as a metascale environment, one that is kind of above and beyond all reasonable scale. You can sit in this room, and in this room alone, we can have several different microclimates. We also realized that when you go to hook up a sensor, there's never wireless coverage where you really want it. And there's sure as heck never an AC plug where you need one. And we thought about, you can't very well sell a sensor for 20 bucks and give someone a 1,000-foot extension cord. That's really not going to win. And so, and in fact, in a place where first responders train, if a chlorine spill or something happened as a rail car or whatever occurred, that first responder would love to have a little gadget he could stick to a stop sign and say, is the gas present here? Is it on the next block? Is it on the next block? So how do you make devices easy to deploy, fast, immediately connect to the cloud, immediately learn, start determining by itself and amongst other devices, this is what I see here, start reporting. And so we had to really rethink that architecture of every device. And what we came across is we went back to the facility, it was still hot, and started analyzing all the climates around it and how air moved. And we said, we got to start with people first. We are the greatest data capture devices on the planet. We sense things that is very hard for lots of computers to determine. Not to mention the fact that we're all here, and so let's not build a system that makes us all obsolete. So some really neat fun things, a little band, Microsoft band that reads my heart rate, my blood oxygen, my skin temperature, and can report that. Tells where I am. That's good information. But it's really great information when my heart rate goes spiraling up and my skin temperature collapses. That's an actionable item. I'm hoping someone sees that alert to come get me. If I arm everybody with a tablet or a computing device, one that's safe, now all of a sudden, as I read this gauge and the device, whether or not it's connected or not, says, based on that reading, you should go over here and turn this thing off. Now all of a sudden we're acting in real time. We're averting disaster in a very, very different context. From a first responder to a person in an industrial environment. So when we start to think about different architectures, Gartner has defined 5 architectures. I'll go through those. We see it as actually a mix and match of all 5. It's not any one when you're dealing with these kind of metascale environments. So we started to analyze the environments themselves. And we created a whole range of different environmental sensors. Wind direction, humidity, speed, things like that. And with a cloud-centric architecture, it starts to make a difference that on the east side of the property, we're detecting the sunrise, which helped explain why all the temperature sensors started to rise. Simple kind of machine learning across that infrastructure, but it also helps alert you when temperature sensors start to rise at 2 o'clock in the morning. Those little things become kind of big inclusiveness. And also we found out is that if you put one big weather vane up at 50 feet, that sure as heck doesn't tell you what's happening where I'm breathing. Because we've all walked through downtown or whatever, the wind changes around buildings and through things and so forth, and a car driving by creates a different wake, and people walking create a wake, and they will carry the gases and dust with them. So that human element and how we measure the environment across that becomes important. Then you get to devices. We want to know exactly what's happening. If a single sensor has detected a rise in benzene, that's all it needs to know. But it's worth alerting by itself. It doesn't necessarily need to be connected, but it needs to be connected across that infrastructure, because as soon as that one gas sensor goes off, I want to see that that plume doesn't just simply move in a circle. It actually moves based on those specific environmental conditions. But it still wasn't enough. And so we had to add a different type of infrastructure, a gateway-centric one. Because devices and power and wireless never really fits the way you want it, a single little cheap sensor over here that has a very low power radio that can talk to a gateway over here, and another one, and another one. And amongst that cluster, they themselves can learn, and that one gateway can communicate. We can back all that information that way and feed into the system. But we only need to know when there are certain exceptions and so forth. But the intelligence around a single cluster and a gateway can start to change how you overlay a system. And it's still not enough. Enterprise grade. Some information ought not just be flying out into the airwaves. Some of it is very specific to an enterprise, where on-premises cloud computing exists versus the big Azure cloud or otherwise computing. Connecting those devices, connecting what's happening in a laboratory or whatever, yet overlaying it across the existing plane of the organization, changes how you see things. To do that at 800 acres was insignificant in cost compared to the benefit. The time to do it just took time to kind of figure it all out. So we're able to do some really fun, neat things. And to kind of summarize, how do we see it? Well, we found out that building just a device for us, because we work in hazardous environments, gas very seldom decided that this line meant that I'm not allowed to pass here. So having a regular device and one designed for a hazardous environment, we just decided they all need to be designed for that hazardous environment. They ought not spark. They ought not generate enough heat to ignite the place. So they should be safe, and they should be intelligent. There should be enough machine learning on that individual device to make its decisions. Secondarily, those devices need to connect all sorts of things, but we also need to connect people. It matters. We matter, and it's nice that all of that works in a single plane. And lastly, you need to take into concept this meta scale. How does it affect across an entire urban environment, a city, an industrial complex? What type of testing is necessary to do that? And how does that overlay with our education community? Because this takes effort, it takes people, it takes thinking. It takes great facilities and great training to do it. But with a little bit of effort, we can change industries, we can change the planet. And that's all I have to say. Thank you.